Okay, this week we've been looking at the eye and how it detects light. So the outer part of the eye is called the cornea, and this is a transparent layer that protects the eye. And if we have a look at our eye model, this part here represents the cornea. Transparent, very tough part of the eye that protects. Now the colored part of the eye is called the iris, and the iris is actually a muscle. So we've got a muscle here, and this muscle changes depending on how much light there is. If there's a lot of light, then these muscles close up, and the opening to the eye, which is called the pupil, which is the it's basically a doorway into the eye. In bright light, the pupil is very small. In dark light, the iris, the muscles open up, the door gets bigger, and more light comes in. So if we have a look at our model, so we take off the cornea, this represents the iris, and here is just the pupil, what we see as the dark spot, which is simply an opening. Then that light goes through the lens. The lens is a convex lens, and this bends the light and focuses it on the back of the eye, the retina. So let's have a look at our model. So if we remove the iris, we can now see the lens convex shape. Okay, if you have good eyesight, the lens focuses the image and it hits the back of the eye called the retina. And the retina contains cells called rods and cones that detect light. The rods detect dim light, and the cones detect color light. And if we have a look at our model here, this is the back of the eye called the retina. So light would come in, lens would be here, and light would be focused. Now, you have a blind spot, and there is one of the stations, station 4. You can do that, and so you can find out that you have a part of the eye where you don't detect any light. And the blind spot is because of the optic nerve. Here you can see the retina is shown as an orange line. Here you can see there's no retina on the optic nerve. If light falls on there, we do not detect it. It's the blind spot. And here we can see the optic nerve here. The optic nerve sends the information to the brain. Now what the brain does, and the optic nerve, even though we don't see any light falls on the optic nerve, the brain guesses what we should see. So it looks around the optic nerve, looks at the picture around the optic nerve, and guesses what we should see and fills the information. Okay, if you do station 5, you can find out whether you're colorblind or not. If you are colorblind, that means that there's something wrong with your cones, and these are the cells in the back of the retina that pick up color. So colorblind is something to do with your cones aren't working. Okay, station 3 involved staring at this picture for a minute and then looking at a white piece of paper. And when you did that, you noticed that you got the correct colors of the American flag. So why did this happen? Okay, well, when we look at a white piece of paper, we know that white light, so when we're looking at white light is a mixture of all these different colors. And let's say we stare very hard at a piece of red paper. When we then switch to looking at white paper, our red cones don't work as well. So instead of getting all the mixture of colors to make white, the red part is removed, so we're now getting a new color. This will become a little bit clearer when we look at color in the next couple. Now, we need to be focusing our eyes, and the focus depends whether we're looking at something far away or close up. And we do that by changing the thickness of the lens. So you can see here and here the lens is a different thickness. Here, seeing close up, the lens is quite fat, and here, seeing far away, the lens is a lot thinner. Okay, one more thing. When we focus, so let's say we're looking at this person. When we focus and the light goes through the convex lens, the image of what we're seeing is upside down on the back of the retina. This information gets sent to the brain, and the brain flips the image the right way up.